Welcome to this lesson on angular velocity. Angular velocity is a fundamental concept in understanding rotational motion. It helps us describe how fast objects rotate around an axis, measured in radians per second. Throughout this lesson, we'll explore what angular velocity means, how to calculate it, and where we see it in the real world. Angular velocity describes the rate of change of angular position with respect to time. In simpler terms, it tells us how fast an object is rotating. Unlike linear velocity, which measures straight-line motion, angular velocity measures rotational motion. It's important to know that angular velocity is a vector quantity, meaning it has both magnitude, which tells us how fast the rotation is, and direction, which indicates the axis and sense of rotation. The formula for angular velocity is omega equals delta theta divided by delta t here. Omega represents angular velocity, delta theta is the change in angle measured in radians, and delta t is the change in time. This formula tells us that angular velocity is simply how much the angle changes over a given time period. The larger the angular displacement in a shorter time, the higher the angular velocity. Angular velocity is measured in radians per second, abbreviated as rad/s. This is the standard unit used in physics and engineering. While degrees per second can also be used for angular velocity measurements, radians per second is preferred because radians are the natural unit for measuring angles in mathematical calculations and physics equations. To convert between radians and degrees, remember that 1 radian equals approximately 57.3 degrees. For example, if an object completes 1 full rotation per second, its angular velocity is 2 pi radians per second. The same rotation can be expressed as 360 degrees per second. Understanding this conversion is helpful when working with different measurement systems. Angular velocity is closely related to linear velocity through the equation v equals omega times r here. V is linear velocity, omega is angular velocity, and r is the radius or distance from the axis of rotation. This relationship shows that linear velocity depends on how far an object is from the rotation axis. Points farther from the center move faster in terms of linear speed, even though they have the same angular velocity. Let's look at some real-world examples. Earth's rotation has an angular velocity of approximately 7.3 times 10 to the power of -5 radians per second, which corresponds to 1 complete rotation every 24 hours. A typical ferris wheel at an amusement park might rotate at about 0.1 radians per second, giving riders a smooth and enjoyable experience. These examples show how angular velocity applies to objects of vastly different scales. Let's review the key takeaways from this lesson. Angular velocity is measured in radians per second. The formula is omega equals delta theta divided by delta t. Remember that angular velocity is a vector quantity with both magnitude and direction. Finally, it relates to linear velocity through the equation v equals omega times r. Understanding these concepts will help you analyze any rotational motion system. Angular velocity is essential for describing how fast objects rotate around an axis.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.